started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be exploring loops in Python, and we're going to be starting with the while loop. In a follow-up video, we'll be taking a closer look at for loops, but for this video, we're going to be focusing in on the while loop. But before we get into while loops, what are loops, and what do they mean in programming? Well, loops are control structures that allow us to iterate over the same block of code multiple times. So what do we mean by iterate or iteration? This means executing the same block of code over and over again. So far, the examples we've seen in this class have been fairly linear, maybe with some branching with if statements, but they tend to start at the top and head to the bottom of the source file. We haven't seen a way to go back yet. Loops are going to give us the power to repeat things. There's two different types of iteration in most programming languages: indefinite iteration and definite iteration. In indefinite iteration, the number of times a loop is executed, that means how many times we run a certain block of code, isn't set in advance. Instead, we keep running the block of code until some set of conditions is met. The other type of iteration, that is definite iteration, the number of times the block of code is going to be executed or repeated is set in advance explicitly. So how do we actually implement this in Python? Well, Python provides us two primary types of loops. The first is a while loop, and the while loop repeats a block of code over and over again as long as some specific condition remains true. This would be some Boolean condition that we set at the beginning of the loop, and these are typically used for indefinite iteration. The next type of loop would be the for loop. For loops iterate over a sequence or collection of elements, for example, characters in a string, elements in a list, or a range of numbers. Now, this would usually be used for some type of definite iteration. But I should note that you can use either loop for either type of iteration, but this is what they are typically used for, and they tend to work best or are easiest to use with that type of iteration. Let's take a look at an example. Before we get into any code, let's represent this as a flowchart. That means we're just going to be looking at the logic of the algorithm rather than how it's implemented in Python. But don't worry, we'll get there later in the video. In this example, we have a problem where we want to allow a user to input the cost of any number of products in their order and output the total with tax. When the user inputs a negative number, they're done inputting product costs and we exit. The idea here is we don't know how many products the user is going to input. They're going to input any number of products. It could be 1, it could be 1,000. This means it would be hard to code this without loops, as we couldn't just keep writing over and over again the different input statements. For one, that would take forever, and the other issue would be that there would always be a case where the user wants to input one more product than what we wrote input statements for. So what do we do in a case like this? How could we do this? Well, let's first explore the solution in a flowchart. So in this flowchart, we start at the start node, shown here as a green circle, and we initially set the variable total equal to 0. This will be a variable we use to keep track of the cost that the user has input so far. Since we're at the beginning and they haven't input anything yet, we're going to start at 0. But the idea here is each time they input a new number, we're going to add that to our total here. Next, we're going to ask the user to input a cost of a product. In this case, let's say they input $10.99. So far, this is pretty straightforward. We could already code this with what we've covered so far in the course. But the issue here is we want to repeat this. We want to keep asking for the cost over and over again until they input a negative number. This means we now need to make a decision of sorts. And that is shown here in this green diamond, and that's how we represent decisions in a flowchart. This decision is the cost negative? We want to keep inputting numbers until they input a negative cost. So in this case, 10.99 is not a negative number, so we'll add the cost to our total. The total now becomes $10.99. This is also where the loop comes in. Instead of continuing on somewhere else in the program, we go back to the input statement. This time, let's say the user inputs $3.75. Again, we check if the cost is negative. Nope, it's not. So we add that cost to our total, and our total becomes $14.74. We loop back, and we again ask the user, and let's say this time they input -1. Is -1 a negative number? Yes, it is. So we exit the loop, and we calculate the sales tax on the total. In this case, let's say we use 13% sales tax, and we calculate the total cost with tax to be $16.65, with a little bit left over. We then output the result to the user, and that looks something like this. Your total with tax is $16.65 odd cents. Lastly, we are out of instructions, so the program ends. So we don't yet know how we can implement this in Python, but we have an idea of what the algorithm looks like that we want to implement. We'll come back to this, but first we need to learn a little bit more about while loops. As we mentioned before, while loops repeatedly execute a block of code as long as a specific condition remains true. Let's take a look at what the syntax looks like. First, we have a while keyword, and this is a keyword we use to tell Python we're starting a loop. That's followed by a condition. The condition has to be an expression that results in a Boolean value. It could be as simple as just saying while true, that would be a loop that runs forever, or it could be a logical expression that compares values like x equals 1, or x is greater than 1, or it could even be a variable that stores a Boolean value. For example, we could say while flag, where flag is a variable that contains the value true or false. Now, inside the while loop statement, we have a block of code to be executed multiple times. Right here, we just have it as a comment that says statement to be executed, but it does have to be one or more lines of real code. These will be run over and over again multiple times, so long as the condition of the while loop remains true. Now, there is an important note here about how Python handles indentation. In Python, indentation is very important, as it tells Python what code is in what blocks. So just like we saw with the if statements, we need to use indentation to tell Python what lines of code are inside of the while loop and what lines of code are outside of the while loop. Every line inside the while loop should be indented at the same indentation level. These could be tabs or spaces, but remember the PEP 8 style guide recommends 4 spaces. And most Python IDEs, even if you hit a tab, will insert 4 spaces for you. So you usually don't have to worry about that too much. Let's now take a look at an example. And we have a fairly simple example here that counts from 1 to 10. Pretty straightforward. The first important line here, other than setting count to 1, is the condition of the while loop. The condition given here is count less than or equal to 10. This means the loop is going to keep running so long as count is less than or equal to 10. Once it becomes larger than 10, such as 11, it will stop running. However, it's really important to understand when this condition is checked. It's only checked at the start of a loop, or at the start of every iteration of the loop. Inside the body of the loop, we have 2 lines, print count and count plus equals 1. Let's start tracing through this code just to get an idea of how it works. First, we print out counting from 1 to 10, and then we set a new variable named count to 1. This will sort of be our index for the loop. It's going to keep track of what iteration of the loop we're on. It's also going to store the value we're counting. At the very start of the while loop, we have to check if the condition is true. We don't start the loop at all if the condition is false. Here we're asking if count is less than or equal to 10. Count's currently equal to 1, and 1 is less than 10, so this would result in true. As this is true, it means that we're going to enter the while loop and run the first line contained in it. That's going to print out the value of count, which is 1. So we get a 1 in our output. And you can see this in the output window on the screen right now. Next, we add 1 to count, and the value of count is incremented to 2. This also means we've reached the end of the block of code in the while loop. This is where something special happens. Since this is a loop, that means we're going to restart the block of code. And execution is going to jump back to the start of the while loop. The while loop restarts, and this is where we check the condition again, and now count has been incremented to 2. The condition is 2 less than or equal to 10. This is true, so we're going to enter that loop again. The first thing we do is print out the value of 2, and that is what's currently stored in count. And then we increment count to 3. The loop restarts again, and the condition is checked again. In this case, 3 is less than or equal to 10, which is still true. This keeps on happening. We keep going through, incrementing the value of count and printing out the values, until eventually we get to printing out 10 and count equals 10. Then we increment the value of 10 to 11. The loop restarts one last time, and we check the condition. But this time the condition would be 11 less than or equal to 10, because count's now equal to 11. Finally, this results in a false, and the loop terminates. This means that we jump down to whatever line of code is first after the while loop. In this case, there's no lines of code after the while loop, so this means we're done the program and it terminates. Now, look at the output here, and we can see the numbers 1 to 10. But the last value of count is 11. The reason for this is that we printed out the value of count before we incremented it. So in that last run of the loop, it output 10, it incremented count to 11, and the loop restarted. We checked the value again, it resulted in false, and because we never ran that loop again, we never got that last value of count equaling 11. When dealing with loops, it's very important to understand these kinds of boundary conditions and what values you're actually running to. The order of the print line and the line that increments count in the loop is also very important. If we were to add 1 to count before we printed it out, we would have a different output that starts at 2 and runs up to 11, instead of running from 1 to 10. So the order of the operations in the loop is important. To explore this a bit more, we have 3 different examples here. What I'd like you to do is take a few minutes, take a look at each of these examples, and try to predict what the output will be. Pause the video, and when you think you have an answer, unpause the video. I'll put up a timer, but again, feel free to pause the video and take all the time you need.
Lines of code on screen again. Python's flowing through my pen. Hourglass is running out. Gotta solve this right, no doubt. Deadline's looming, it's so tight. Tick-tock goes the clock at night. Functions, loops, and ifs and else's. Each line fixes all my messes. Coding fast, time is slipping. Got no pause, pressure's gripping. Python rhythm, keep on beating. Countdown timers, never cheating. In the zone, my mind's a maze. Debugging errors that we face. Syntax highlight, guiding way. Hope to reach the break of day. In the zone, my mind's a maze. Debugging errors each iteration. A variable dreams never ending. Python logic with
And we're back. Now, we're going to start by taking a look at example 3e. In this example, you can see that we're starting count at 0, and we're running the loop as long as count is less than or equal to 10. Now, one new thing here, other than starting count at 0, is that instead of adding 1, we're adding 2 each loop. Here's the output. And we would get what is effectively counting by 2s, up from 0 all the way to 10. The way this works is we start counting at 0, and since we print before we add to count, that means the first value output is 0, then we add 2 to get to 2, then 4, 6, 8, and 10. And in the last iteration of the loop, we add 2 to 10 to get 12, and this causes the condition to be false. So when the loop restarts and the condition is checked, we exit the loop and the last value of 12 is not printed. Let's take a look at another example. In this case, example 3D. In this one, we're running the loop backwards. This is done by starting count as a high value, in this case 10, and inside the loop we are subtracting 1 each time. Another important feature is the condition. Here the condition is checking a lower bound, asking if count is greater than 0. This works as we are subtracting from count rather than adding. Count starts at 10, and each iteration of the loop, it prints out the value of count and then subtracts it by 1. This means we get 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. In the last iteration, when we output 1, we subtract 1, and we will end up with a 0. 0 stored in count, and the condition when we start the loop is 0 less than 0, which is false, and the loop exits. In the last example here, this is very similar to the first example we saw, except we have shifted everything down by 1. We did this by starting count at 0, and we changed the condition of the loop so it's no longer inclusive of 10. It's now exclusive of 10. We did this by using less than rather than less than equals. So now if count equals 10, it will return a false instead of a true. This means we start at 0 and keep adding 1 until count is equal to 10, causing the condition to be false and the loop exiting. So here we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and no 10. Now, there is one other important thing we should mention about loops, and that is infinite loops. This is a common error when programming with loops, and it's caused by creating a condition that can never be false. This is a big problem because, as you may recall, while loops run as long as the condition is true. If that condition can never be falsified, that is, never return false, that means the loop is going to run forever and it's never going to stop. That means the program will never terminate unless you manually force it to stop. Here's an example, and try to avoid this in your coding, it's definitely a bad example, where we have a loop that looks similar to the ones we saw before, but there's a logic error here. Do you see what it is? In this case, the condition for the while loop is checking a lower bound. Is count lower than 0? But instead of subtracting from count, like we saw in a previous example, we're adding to count. That means the value of count is only ever going to increase. It's going to go up and up from 1, 1, 2, 3, 4, 5, and so on. It's never going to go below 0, which means the condition will never be false, and this loop will never stop. So what will this look like while we run it? Well, let's try it out and see. Okay, let's run this program and see what happens. You can see what's happening here. The numbers are just getting bigger and bigger very rapidly. It looks like a little bit like it's lagging, as the program's just going by so fast, but this is not going to end. Well, technically, eventually the computer will probably run out of memory. As the number gets so big, it will take up the whole block of memory allocated to the program and it will crash, but that's going to take some time. So if you get into a situation like this, where you accidentally create an infinite loop and you need to stop it, don't worry, you just need to hit the stop button in your IDE. Then you should be able to go through your code, find the logic error, correct it, and try running it again, and hopefully you don't have an infinite loop the next time you run it. So let's close this and continue on. The next topic we need to discuss are Sentinel values. And these are special values that we use to signal the end of a loop. They're especially useful in situations where we don't know how many times the loop needs to iterate in advance. A great example of this is when we're processing user input. Perhaps we want the user to input a bunch of numbers or values. In such a case, we could do something like we saw in the flowchart at the start of this video, and ask the user to input a negative number to denote that they're at the end of their input. This negative number would be the Sentinel value. As an example, let's say we want the user to input any number of words and count how many times the words start with a vowel. That is, how many times does the first letter of the word start with an A, E, I, O, or U. Once they input a hash sign, that is the number sign or the pound sign, then we would exit and print the total. We also want to ignore capitalization. So it doesn't matter if it's an uppercase vowel or a lowercase vowel, it should be counted the same. In this example, the hash sign would be the Sentinel value that will signal the end of the user's input. So here we see a potential solution to this problem. But before we try it out in PyCharm, there's a few things I should mention. Some of the lines you might be familiar with, like the comments and the total equals 0, which simply assigns 0 to total. But there are a few others we should take a look at and talk about now. First of all is this input line. And this is what we call a priming read. Later on in the code, we need to test the value of the variable word to see if we are going to enter the loop or not. But we need some sort of initial value to test. And there's a few different approaches we could take. Sometimes you might see programmers use a dummy value, such as setting the word to an empty string. But another approach, like we're doing here, is a priming read. This is where we do an input read before the loop even starts, just to start word off with a valid value. The other important thing about this line is the use of the strip method. You may recall from our video on strings that this method removes any trailing or leading white space. The reason we're doing this for this program is that it's very sensitive to what the first character is. We're checking if the first character is a vowel or not, so we don't want the user to accidentally input a space before they input the first word. So this will remove any trailing or leading white space to remove that issue. Next, let's talk about the condition for the while loop. Here we're saying run this loop so long as word is not exactly equal to the hash sign. And this hash sign is our Sentinel value. As soon as the user inputs the hash sign and the condition is rechecked, we exit this loop. This also means that if the user initially inputs a hash sign as part of that priming read, we're going to skip this loop entirely, and we are going to just terminate the program. Now, I should note that this hash sign does have to be the hash sign exactly. It's not going to exit if it's ABC hash sign or hash sign ABC or any other characters. This will not exit. It has to be exactly equal to just the hash sign. The last thing I'll mention before trying out the code is this input line inside the while loop. This is what we call our modification read. This updates the value of the word in the actual loop. The priming read gets the initial value outside of the loop, and the modification read keeps updating it in the loop every time we reiterate the loop and input a new value from the user, so word isn't equal to the same thing every time. Okay, let's go try this out in PyCharm. Here we are in PyCharm, and we're going to start by just trying out this program by running it. Okay, and it's asking us for input because we're currently at this input line here, which is our priming read. So let's put in duck. And you can see I hit enter, but it's still looking for input. The reason why is the second read, the modification read, doesn't have any sort of prompt to the user. So that means it's just asking for input, allowing us to put in a list of values, and it's not going to keep outputting anything. So it's waiting for us to input another value. So in this case, I could put it by like Python. Even though it says a word, it is accepting whole strings. Say at, hat, cat, maybe egg, input. Just need some words here. And now when we want to exit, we have to put in the Sentinel value. And that is the hash symbol. You can see once the hash symbol's in, it exits and it says the total number of words that we input that start with a value are 4. We can see that's true. I like Python would count because the I. At counts, so that's 2. Egg would be number 3, and input would be 4. So it is correct. Okay, we're going to set a breakpoint right here at the start of the loop, and we can run this in debug mode to see how it works. So again, it's asking us for input. This is the priming read. Put in duck again. And we've made it to the breakpoint, and it paused. And we can see we have 2 values right now. We have total, which we initialized to 0, so that makes sense that it's still 0. And we did the priming read, which currently has duck in the string. So we're paused right here at the while loop just before we enter it. And it's going to check if duck is equal to the hash symbol. It's not, and since it's not equals, that means we are going to enter the loop. So we can step in. And what we're doing now is we're checking if word, specifically the first character in word. Remember, this is how we index a string. So this is saying return the character at index 0, which would be the D in duck. We're going to convert it to lowercase, so it'll be a lowercase d. And then we're going to use the in operator, which we saw in a previous video, to check if it is in the string. So that means it's going to check if the lowercase letter d is one of these values. Is it an A, E, I, O, or U? It's not in this case, so that is going to evaluate to false, which means we're going to jump over this. We're not going to run total equals +1. Instead, we're going to go right down here to the modification read. We can see that. Yep, so we jumped over, and now it is going to ask us to input another value. You can see in the console, it's asking for input. In this case, we'll put one with a start with a vowel. So we can say, we'll just use egg again. So what has happened is since we're at the end of this code block now, we jump back up to the start of the loop. Python knows we're at the end of this code block because there's no more lines that are indented to the same level. Since there's no more lines, that means we go back and restart the loop. In this case, it's going to be checking if egg is not equal to the hash symbol. You can see word is now equal to egg because our modification read updated it. So we'll go in, we're going to run the loop again, and now we are checking if the first letter of egg converted to lowercase is in A, E, I, O, U. In this case, it is because E is in the string. So what should happen is we should enter this if statement. You can see we do. We go down to total plus equals to 1. And when we run that line, it will increment our total. So our total is now equal to 1. And now we're going to input another string. So this case, let's try out that strip method. So remember, we put a bunch of leading space. And we'll put in the word, let's say in, and a bunch of space. So we've inputted the word in with a lot of space at the beginning and the end. But you can see in the computer's memory, it's just in without the space at the beginning and end because the strip method removed all the space at the beginning and the end. In this case, we're now running the loop again. Is in equal to hash sign? Nope. Now in the first character at index 0, converted to lowercase, is that in A, E, I, O, U? In this case, it is. It's right there. So we should enter into the loop again, or the if statement rather. We're going to add 1 to our total. So our total is now 2. And then we're going to take input again. In this case, we'll do another test. So we'll say the word test. 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 And you'll notice that I put a bunch of space at the beginning and the end. So let's see what happens this time. So we put in space, 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 test, space, test, space, test. And you can see in the computer's memory, the leading and trailing spaces are gone thanks to strip, but the spaces in the center, or in the middle rather, are not affected because it only removes trailing and leading spaces. Again, we test if that's equal to the hash sign. It's not. Now we're checking if the first character, the T, is in there. It's not, so we're not going to enter the if statement. We're going to jump over it. And we're going to input another one. This time we'll put something in uppercase. Let's see. Let's try I love Python. We can take a look. That's now in the memory. And you can see strip didn't remove the spaces inside. It only removes on the outside. Restart the loop. That's not equal to a hash sign. Now word at index 0, that's going to be an uppercase I. It's going to convert it to lowercase and then check if it's in the string. In this case, it should be. It should match the lowercase I. So we will enter the if statement. And we're going to increment total again. So now our total is 3. And now we're waiting for input again. This time we'll put in the hash symbol. This is our Sentinel value, so it should make us stop. Okay, so we can see the string's now equal to exactly the hash symbol. We've restarted, so it's going to check word not equal to hash. This is going to be false because it is equal. And when this becomes false, it means we're going to jump out of the loop. And we go to the first line after the loop, which in this case is the print line. It's going to say the total is whatever's currently in total. And we can see that is equal to 3. So in the console, we should get the total is 3. And we do. So that seems to be working okay. Okay, let's head back to the slides and take a look at some more examples. And we're back to the slides. And we finally know enough now to start trying to code that example that we saw at the beginning of the video. If you recall, that was this flowchart here, which shows the algorithm for allowing the user to input any number of costs, adding all those costs together, and then calculating the sales tax on them. And we exit when the user inputs a negative number. So let's switch over to PyCharm now and code this together. Here we are in PyCharm once again. And you can see I have a picture of the flowchart up here so we can easily refer to it as we're coding. We're going to start by creating a new file. In this case, we're going to right-click on the project. We're going to go New. We're going to go Python. We're going to call this file costs. And we could put .py, but even if you don't put .py at the end, it does add it for us. Close that so we have some more room. If we look at the flowchart, the first thing we need to do is set total equal to 0. The reason why is total is going to keep track of the costs as the user inputs them. Each time they input a cost, we'll add that to our total. Speaking of which, the first thing we're going to need to do after setting total equal to 0 is to do a priming read and get the first value from the user. We're going to say cost equals input. And we're going to just ask the user to input the cost of a product. Now, one thing we do need to do here is convert this. So right now, this is going to be a string type by default when we input it from the user. And we want that to be a floating point number. It has to be floating point, not integer, because costs, like product costs, could have cents on them. So it could have decimal places. So we're going to use the float function to convert this to a floating point number. That's one that can have decimal places. So next, if we look at the flowchart, we have to actually do a check. Now this check isn't an if statement. This one is actually the condition for a while loop. So we're going to say well, and we know we want to keep running this loop until the user inputs a negative number. So that's going to be our condition. Is cost greater than equal to 0? In this case, we're saying greater than and equal to because 0 isn't negative. So we don't want to count 0 as a negative number. So we want to be inclusive of 0, so that will still result in a true. So only if it's a negative number will that result in false, and we'll exit this loop. Now everything inside here that's indented is going to be inside the loop, and it will run until the user puts a negative number. So we checked if it's negative. Now we need to add the cost to the total. So at this point, we know the cost has to be positive, because if it was negative, we would have not even entered the loop. We'd have just gone to after it. So we can add the cost to our total. Simple enough. Now what do we need to do? Well, if we look at the flowchart, we go back around and we ask the user for input again. So this would be our modification read. And that's going to be almost the same. Actually, it's going to be exactly the same as our priming read. So we can just copy and paste it there. So it's going to ask the user again, input a cost for the product, negative number to exit. What will happen is after they input that, we'll go back around, you'll check it again. If it's not negative, you'll add it again and ask them for a new number. If it is negative, then we exit and go down here. So now that we're outside the loop, that means we're going down this no path here in the flowchart. The reason why is we can only get to this point in the code if this is false. So we know that cost is now negative. So the next thing to do is calculate and add the sales tax to total. And to start, we need to know what the sales tax is. So we'll assume that it's going to be equal to the sales tax in Ontario. So that's tax rate. We'll say 0.13. Now, the reason why we put tax rate up here like this is because this is sort of a constant. It doesn't change too much, but it changes enough that we want to make it easier to change this and update it if for some reason the sales tax rate changed in Canada. And remember, it's good practice to put our constants in all uppercase, just to signal to other programmers that might be reading it that we shouldn't change the value of this after we've set it. So now we can do the calculation for adding the sales tax. So that'd be total. We're going to do multiplication equals tax rate plus 1. So what this is doing is it's taking the tax rate, adding 1, so it becomes 1.13, and then it times total by that amount. That will give us the total with tax, and then it returns that value and stores it back in total. So the last thing to do is to output the total. We can do that with a print line. And in this case, I'll do a /n. That's an escape sequence. That means add a line break, just to give us an extra line after the input. Oop. And I guess we'll use an F string. So let's try giving this a run. Let's say our cost 10, 100, and 1,000, -1. And our total is 1254.3, which looks okay. But what if we had some other kinds of numbers with decimal points? So this is working okay, let's hope. But you can see that we get a lot of those extra decimal places. And you don't usually get a total with a ton of extra decimal places. Usually it's only down to the second decimal place. So if we want to do that, one way we can do that with F strings is by putting a format specifier that says round this to 2 decimal places. And the F means that it's a floating point value. Let's give that another try. Let's put one with a lot of decimal places. And you can see that it rounded it nicely for us. And we're back, and I have another example of solving that same problem, just so you have it in your slides as well. This should be almost identical to what we coded. I just created it earlier, and it still uses that priming rate. And here's an example of the output. So if you'd like to review that again, it's in the slides, and these files should also be attached to OWL in the list of examples in the video resources box that you should be able to see down here if you're watching this on OWL. If you're watching it on YouTube, you would have to log into our learning management system to find those files. Now we're going to take a look at a few more examples just to make sure we fully understand while loops and the ways we can use them. And our first example is going to be years to reach an investment goal. And what we're trying to do here is create a Python program to calculate the time in years for an investment to reach a set target. Assume interest is compounded annually. The user should input interest rate, initial investment balance, and the target balance. The output should be the number of years to reach the target and the balance of the investment at that time. Add some simple error checking to check for invalid values, but still assume the user will input the correct data type. For example, they'll input a number and not something silly like the word pizza or duck. So can assume they're always going to put in a number, but it might be not a sensical number. So here we want to do some error checking, but nothing too advanced. We're not going to be checking for something completely invalid, like putting in the word banana rather than a number, but we could check the balance of those numbers and make sure they make sense. For example, they should not have any negative numbers for an investment goal or a negative interest rate. So here's an example of the input and output for this program and what that might look like. The user inputs an investment target, interest rate, and an initial balance, and the program outputs the number of years it will take, as well as the balance after that many years. So I have the solution here on the screen right now, but rather than going through it line by line in the slides, let's switch over to PyCharm so we can actually run this and get a better understanding of how this solution works. Here we are in PyCharm, and we have the example loaded up. So let's take a look. At the top here, we have our input. So we are taking in 3 values. All of them are going to be floating point values. First, the target, that's the investment goal we want to meet. The rate, and this is going to be a rate input as a number between 0 and 100. And the balance. This is the initial balance of our investment. The next part here is going to be our error checking. So we're going to be checking a few things. We're checking if target is less than 0. In that case, we're going to give an error. And one new thing we haven't seen yet is the exit function. What the exit function does is pretty much what you would guess. It exits the program completely and immediately. So as soon as we get to an exit, the program is done. So in each of these cases, there's some sort of error, and it means we don't want to continue with the program. There's no real recovery from this. We just want to exit. The other check we're going to do if rate is less than 0 or equal to 0, or if rate is greater than 100, then we exit. If balance is less than 0, then we exit. Or if the target is less than the balance, we're going to exit. All of these would make our program not work correctly. Down here is where the actual logic of our program is. This is where we're actually calculating the investment, particularly in this while loop, and then we're printing it out here. So let's take a closer look at this while loop. So we're going to run this loop as long as our balance, our current balance, is less than our target. Inside the loop, we're going to keep adding years to keep track of how many years it takes to get to our target. And we do the actual interest calculation here. It's fairly straightforward. We have to divide the rate by 100 because we're entering it as a number between 0 and 100 rather than like 0.13. And then we simply multiply the balance by that, and that gives us the interest. And then we add the interest to our balance. After this loop finishes, it's going to finish when the balance is greater than or equal to the target. Then we're going to print out our investment. We're using a nice F string here. So it's going to print out the target, rounded to 2 decimal places, the years, and the amount left, or the amount we have after we reach the target, because it will overshoot the target slightly. So let's give it a run. Let's just try running it. So our investment goal, say $2,000. Let's say the interest rate is 6%. And we'll have an initial investment of 1,000. You can see we are getting the correct answer here. So it would take 12 years in that case. Let's try debugging it just to see how it works. We'll start right here at the top. Okay, we're going to print that first line. You can see in the console, we got time to meet investment goals. And now we're going to be asking for some input. So in this case, we'll just try out what we typed in before, just to get an idea how that works. So our target's 2,000. Let's say the interest rate is 6%. And our initial balance will be 1,000. And we can see we've loaded all these variables in, they're type float. And they are as we'd expected in the variables we've set up. Now we're going to do the error checking. So first we're checking, is target less than 0? Target's currently 2,000. So we're going to skip over that if statement. Is rate between 0 and 100? 0 would be exclusive, 100 would be inclusive. So it doesn't violate that. So we're going to jump over that. checking if balance is less than 0. Balance is currently 1,000, so we should jump over that. And we're doing the check, is target less than balance? Our target's 2,000, our balance 1,000, so we jump over. Now we're going to set an initial value for years. You can see years is 0, and that's where we're going to keep track of how many years it took to calculate this balance. Now we're actually entering the while loop, but before we do, we have to do the initial check. Is balance less than target? Balance is less than target, it's only 1,000. So we enter the while loop. The first thing we do is we add 1 to years. We have year 1. We calculate the interest. That's going to be $60 in the first year. And we're going to add the interest to our balance. So our balance is now 1,060. And we go back around and we're going to check. Is the balance 1,060 less than target? It's still less than it. So we go again and we do the same calculations again. We keep going like this, and you can see the balance is going up. Keep adding the interest. Till eventually we're going to reach the point where the balance is going to be greater than or equal to the target, and that's going to trigger the while loop to stop. And you saw it happen there. So the balance eventually made it greater than target, and we exited. And we're back to the slides. And we're going to take a look at one more example before we move on to another topic. In this case, we want to find the maximum number that the user inputs. We'll ask the user to keep inputting numbers, and as soon as they input something that's not a positive integer, that's a whole number, the program should exit and print the largest input that the user input. So anything that's invalid, such as the word pizza, should end the input and print out the largest number input so far by the user. In this case, we can see on the screen right now, the user input 10, 32, 176, 99, 1045, 3, and then the word duck. As duck is not a valid integer, the program should not take any more input. It should stop and print the result, which in this case is 1045, as that was the largest positive integer the user input. The key here is that our program will need to keep track of the largest number it's seen so far, so it can output that at the end of the program. For this problem, let's code it together in PyCharm. And if you think you can solve this one on your own, try writing the program and then unpause the video and see how it compares. But remember, there's more than one way to write a computer program. Just like in your English class, there was more than one way to write an essay about the same topic, there's many ways to write the same computer program. Each program might be slightly different due to the style of the programmer or the approach they're employing to solve the problem. So don't forget that just because your program's different doesn't necessarily mean that it's wrong. The way to check the correctness of your program would be checking it with different inputs to see if you get the correct outputs. Okay, let's go to PyCharm and code this together. Okay, we have PyCharm open, and we're going to make a new file. I'm going to right-click on the project, go New, Python. We'll call this one Max. So the very first thing we're going to do is we're going to ask the user to start inputting numbers. We could use this as a prompt and input, but I don't want to keep saying it over and over again. I just want to say it once at the beginning and just let the user keep entering numbers. So we're going to use print. Now, before we do our input, there's a few variables we should set up. And the first one is we want to keep track of the largest number we've seen so far. So we're going to need somewhere to store that. We'll call this maxNum. And what should we set it equal to? This can be tricky, but we know the valid input range are positive integers. So if we say that a maximum we've seen so far is, for example, a negative number like -1, then we'll know that this hasn't seen an initial value yet, and any valid input by the user is going to be greater than -1. So this might be a good starting point. There are other strategies we could use. We could set this to like a none value or something like that, and then replace it. Or we could do sort of a priming read and set it to that. But setting it to -1 is useful because it'll also act as a flag to let us know if the user never actually input any numbers. So after our loop, if it's still equal to -1, we'll know the user didn't input any numbers, and we should probably tell them that. So now we want to do our priming read. Num will be the value that the user has lost input. Input. In this case, we're not going to give any prompt to input. It's just going to input the number since we just want this one prompt at the top. So you might think our next step would be to convert this into an integer, because we do want positive integer numbers. But remember, we want to exit the loop when invalid input is given. For example, if they input cat or duck or zebra, that should cause the loop to exit. And the problem is, if we convert it right away, then if we put in something like cat or duck, it's going to cause an error. And we don't want that. So we're going to leave it as a string for now, and we're going to do a check on it before. So now we're going to enter the loop. And the check or condition for this loop should be checking if this is a valid positive integer. But remember, num is still a string. And there is a special string method we could take advantage of here. If you recall from our string video, one of those methods is decimal. And what that's going to do is going to check if every single character in the string is a digit between 0 and 9. It's decimal. And this means this loop's only going to run if every single character in the string is a digit. Now, there's a few notes about that. This will work for positive integers because they all have to have decimal numbers. But what happens if they enter like a negative number? We also want to exit if they input a negative number. In that case, the very first character is going to be a dash. And isDecimal doesn't consider that to be a number. It considers it to be a dash character. So it would return false. But how's this going to work for non-integer numbers like 5.6? We only want valid positive numbers that are integers. Well, again, the isDecimal method is going to see the dot. It's not going to see that as a number. It's going to see that as a dot character. And again, it's going to return false. So this check is deceptively simple, and because it's actually checking multiple things indirectly. So it's checking if it's negative by seeing if there's that dash. It's checking if it's not a valid number like cat or duck, because those won't be digits. And it's also getting rid of floating point numbers because it will see that dot and not allow that. So inside this loop, we need to actually keep track of the largest number we've seen so far. So we did a priming read here. So we already have one number to check. And we want to check if that number is greater than the largest number we've seen so far. If it is a bigger number than one we've seen so far, we want to update maxNum to that number because we're kind of keep tracking of who's the largest we've seen so far. So we're going to use an if statement because we're making a decision. maxNum is where we're keeping track of our maximum number. And we could say less than num. So if the maximum number we've seen so far is less than the new number, then we are going to update it. But remember, this is still a string. So we're going to need to convert it. So before this, we could do a simple num equals int num and convert the number back into an integer. So we're checking if maxNum is less than num, then we're going to update the value of maxNum because we just found a bigger number. So if we found a bigger number, update it to that bigger number. And because we set this to -1 to start with, it means whatever the first number is input, as long as it's valid, it is going to be the new maxNum. So at this point, we are still missing something. Do you know what it is? And it is our modification read. If we left the code like this, we get to here and it would restart, and we wouldn't have inputted a new number. And that's going to cause a few issues. First of all, if we're not inputting a new number, this loop's just going to keep running over and over and over again. But it also could cause an error because we're saying num.isDecimal, and isDecimal is a string method. But we converted num to an integer, so it's no longer a string at this point. So we need to fix this by reading in a new num value and making sure that's a string. So we'll do our modification read, num equals input. Again, we're not going to prompt because we just want the user to put one after another. What this is going to do is it's going to input a new string value and store that in num. And this is something we can do in Python that we can't do in statically typed languages, which is converting the type of the same variable. So up here, num is a string. Here, num is a string. Num here gets converted to an integer. And then num gets turned back into a string here with a new input from the user. So when the loop restarts, num is a string again, so we can actually check if it's decimal. Then again, we'll keep going and going and going until this is no longer true. Num is not a decimal. Now we need to do something after the loop. So if after the loop, in theory, we should have the largest number because we keep checking if num is greater than the maximum we've seen so far, and we keep updating the maximum. So by the time we get to the end of the loop, max num should be equal to the largest number we've seen input so far. If the user ever inputs something that's less than max num, this if statement won't result in true, so we won't update it. We'll just input the next number or sort of throw out that value. So let's try putting an output here. There is still something we're forgetting, but we'll try that for now. Nope, max num. Okay, let's try running this. I'm going to input some numbers. 100, 7, 32, 46, 1005, 8, 2, 3, 4. If I didn't put in a 3, so let's put it in now. And now we can put in something silly like pizza. This should cause num.isDecimal to return false and us to exit the loop. And you can see we did. And the number is 1005, which is the largest one we input. But there is something we're missing. Do you see what it is? There is a condition that could happen that would cause probably not a sensible output. Let's see what that is. And that is with the priming read up here. What if the user right away, the first input isn't valid? For example, right away, let's say we say negative 10,000. And you can see what happens is this returns false because it sees that dash. And we never run this at all. That means max num was never updated. So we print the max number is -1, which doesn't really make sense. There should be a different output, saying something like you didn't actually input any numbers. So there is a way we could check for that. And we could take advantage of the fact that it can only ever be -1 if they didn't input any numbers. The reason why is because the only place we update max num is in this loop, and we only do that if this was an actual valid input. So if it still equals -1 by the time we get to this print, that means they didn't input any numbers. So we're going to do if. So if it's equal to -1 still, we'll put print. We could say something like, you did not input any numbers. And then we're going to use else because we only want to output this result here if this is false. So if it's still -1, we say you did not input any numbers. And if it is anything other than -1, we are going to say the max number is the maximum number. Let's see running it now. Okay, so let's put something invalid right away, like duck. And we get you did not input any numbers. Or is it still working for our other case? Let's see. And it is. 102 is the largest number. So this is working. So let's head back to the slides. We're back, and on the screen right now is another version of that same solution, but this one I wrote earlier. You can see there's a few differences here. Remember, I said not every solution to the same problem is going to be identical. Here I did a few things differently, such as using the strip method to remove leading and trailing spaces. That way, if the user accidentally puts a space at the beginning or end of their number, it will still count as a number. The other thing that's different is the condition for the if statement at the end of the loop. You can see that it is if num is greater than max num. Whereas what we did in PyCharm was if max num is less than num. Both of those statements are equivalent, and we could write them either way and get the same result. So again, programs can be different, but have the same result and both be correct. Now we're going to move on to a new topic, and this will be the last thing we cover in this video. What we're going to be taking a look at is the break and continue keywords and what they mean for loops in Python. Break and continue are special keywords that act as control statements that can alter the normal flow of loops. The break statement allows us to exit a loop immediately, regardless of whatever that loop's current condition is, and if that condition is evaluated to true or false. So when Python encounters a break statement, the loop is immediately terminated and control is moved to the next statement after the loop. Continue is a similar idea, except it changes where we go after it's called. In this case, as soon as Python encounters a continue statement, rather than terminating, it skips the current iteration of the loop and starts the next one. So it's basically skip to the next iteration of the loop. So continue doesn't exit the loop, it just skips the rest of the code in the loop and restarts. That might be a bit confusing, so let's take a look at a few examples. We'll start with the break keyword. Here we have an example of a while loop, and we're starting x off at 0. And we're going to run this loop as long as x is less than 5. In the loop, we don't do anything too special. We're simply adding 1 to x, and we're checking if x equals 3, then we're going to break. And the last thing we do in this loop is we print out the value of x using the print function. This is very similar to those counting examples we saw earlier, but now we have an if statement, which simply checks if x equals 3, and if it does, we call break. So the output would be 1 and 2 in this case. But let's explore why by tracing through this code. And we start at the top with x equals 0. And as you know, this creates a variable x, so we'll make a note of it up here, and it denotes that x is currently equal to 0, which is its starting value. And we're going to keep track of that up here as we trace through the code. Next, we get to the while loop, and the check is if x is less than 5, we're going to enter the loop. This is going to be true as x is currently 0 and 0 is less than 5. This means we enter the while loop. The first statement in the while loop says to add 1 to x. So x is now updated to 1, and we move to the next line. This is our if statement, and this is checking if x is equal to 3. In this case, x is currently equal to 1, and 1 does not equal to 3, so we're not going to enter the if statement. Instead, we jump over it and run the next line after the if statement. In this case, the line after the if statement is a print function, and that's going to output the value of x. And this is how we got that first line of output, which is 1, as the current value stored in x is 1. As we reach the end of the loop, we now restart, and we have to check the condition again. In this case, the condition is 1 less than 5, which is true. So we enter the loop, and we're going to add 1 to our number, making x equal to 2. We do the if statement check again. Is 2 equal to 3? No, it's not. So we don't run the code in the if statement. Instead, we skip over that if statement, and we print the next output line, which is 2. We start the loop again. 2 is less than 5. That's still true. So we enter, and we add 1 to x to get 3. Now, finally, x is equal to 3. So that means this is going to be true, and we can go inside this if statement and get to the interesting part, that break statement. Remember, the break keyword makes us terminate the loop regardless of the condition. In this case, the condition was x is less than 5. However, as we've reached a break statement, this doesn't matter, and it means we're going to terminate this loop right now, and we don't even proceed to the print statement at the end. Instead, execution is going to resume at the first line after the while loop. In this case, there's no lines after the while loop, so we terminate the program, and 3 is never output to the console as we skip the print line, making the overall output simply 1, 2. Now, the next example we're going to look at is almost the same program, but the continue statement is used in place of the break statement. And you can see this results in some different output. We get 1, 2, 4, 5, skipping 3. The code here is exactly the same as the last example, but we have a continue rather than a break. Let's trace through the program and see why this impacted the output. As the first few runs for this loop are fairly straightforward, we're going to skip to the iteration where x equals 2. This means the loop has run twice, and 1 and 2 have already been output. The condition is x is less than 5, and x equals 2, which means this is evaluated to true, and we restart the loop. The first line of the loop increments x to 3. As x now equals 3, x equals 3 is true, and we enter the if statement. And we reach our continue keyword. Unlike break, continue does not cause the loop to end. Rather, it forces it to restart. This means execution jumps back to the start of the loop, and we skip that print line, so 3 is not output. This is why 3 is not in the output, because when x equals 3, we continue, and we never make it to that print line. After continue, we restart the loop, reevaluate the condition, checking is 3 less than 5? It is, so we start again by adding 1 to x to make it 4. Since x can no longer be 3, we only ever add to it. We keep going, printing out the values, until x is eventually equal to 5, and the loop and then program end. So our final output is 1, 2, 4, 5, skipping 3 because we hit continue before the print in that case. Let's quickly summarize what we just covered about break and continue. Break causes the loop to immediately terminate and start at the first line after the loop, whereas continue causes the loop to immediately restart and skip any remaining lines inside the loop. These keywords can be incredibly powerful and make our code cleaner and clearer to read, rather than writing overly complex conditions for something like a while loop. Now, let's take a look at some far more interesting and complex examples using break. In this program, we want to have the user input a password. If the password is not rubber duck, exactly written like this with a capital R and a capital D, state that the password is incorrect and have them re-input the password. If the password is correct, output access granted and exit. If the password is input incorrectly more than 3 times, output too many attempts, access denied, and exit. So here's a possible solution. But before we get into it, let's first explore it a bit by running it in the terminal. Okay, we have the terminal up, and we're going to run the program. It's asking us to input a password, so let's start by inputting an incorrect password. I've input pizza and got incorrect password. Let's try cat. Okay, we also got incorrect password, and now let's try putting in the correct password. If we look up a little bit, we can see access granted and the program exits, stating exiting system. Let's try running it again. Let's put in all invalid passwords this time, such as cat, pizza, and even just duck. And that's not going to work because it has to be exactly the same as the correct password, which is rubber duck. In this case, we got too many attempts, access denied, and then exiting the system. We can also try putting it in correctly the first time, and that also works. Access granted, exiting system. So how does this work? Let's take a look. The first thing we see is 2 constants being defined, the correct password, and the maximum number of attempts. Defining these at the top is nice, as it makes it very easy to update this program if we need to. If we need to change the password, it's right there at the top, or if we want to change the number of attempts, it's also at the top. Next, we keep track of the number of attempts we've seen so far and start it off at 0. One thing we haven't seen so far is this condition for the while loop, which is simply just true. This is valid syntax. The condition can be any expression that results in true or false value, and just saying true is fine. And that means this loop is going to run forever, as it can never be false. Now, that might seem like it might cause an infinite loop, which would be a problem, but we're using a break statement inside of the while loop, and because we're using this break statement, it means it can exit the loop in another way, and this is a common way we see in programming that we see break used to exit a loop, even though it's a while true, which seems like it should be an infinite loop. So you can have a loop that runs forever while true, and then under special circumstances, such as the password being correct or guessed too many times, we then break out of that loop manually using the break statement. Inside the while loop, we have a few things. We input the password, then we check that the password is correct. And if it is, we output access granted, and then we use break to exit the loop. The other case is if the password is incorrect. If the password's incorrect, the else statement is triggered, and we output incorrect password, and we increase our attempts count. Next, the last thing in the loop is a check that the attempts are over the maximum allowed. If the attempts are over the maximum allowed, we output too many attempts, and we use break to exit the loop. As there's one line after the loop that outputs exiting system, this is output whenever the loop ends. I have a few more example outputs here that you can take a look at in the slides if you're interested, but for now, we're going to move on to our last example. Okay, let's take a look at our last example. And this example is going to use both break and continue in the same loop to solve a problem. And that problem is going to be input any number of positive integers from the user and find the average. Exit when the user inputs the word exit. If any invalid input is given, ask the user to input a new number. This means we're going to keep inputting numbers until the text exit is input, and then we're going to compute the average of the valid numbers they input. Valid numbers, again, would be positive integers in this case. Here's the program. And at the top, other than some comments, we're doing two things. We're setting up the variables total and count, and we're initializing these to 0 to start with. Total is going to represent the sum of the valid numbers we've seen so far, and count is going to represent how many valid numbers have been input. We're going to need both of these values to compute the average at the end of the program, which will be equal to the total divided by the count. Again, we are going to be using a while loop with the condition of simply true, just like in the last example. This means the loop is only going to exit after it encounters a break statement. The first line in the loop inputs the integer from the user, or if they put in some text, maybe they input text if they wish to exit. This means exit is going to be our Sentinel value. After we input the value, we check if it's equal to exit in all lowercase. And if it is, we're going to use the break statement to exit the loop, which would jump down to the first line after the loop, which is this if statement that computes the average. But we also have a second if statement with a continue in the loop. This if statement checks if the input is anything other than a number, and it does this using the isDecimalString method. The isDecimalString method returns true if all characters in the string are numbers. Otherwise, it returns false. This check is going to work for both checking for invalid text, maybe something like pizza, but it will also work for checking for negative numbers and numbers with decimal places, as isDecimal would return false if a character has a number or a negative sign, or if the character contains a decimal point, as these are not considered to be number characters. So you're doing 3 checks in one here. If it's not a number like pizza, duck, something like that, it's going to return false. If it has a negative sign, it's going to return false because it doesn't think that's a number character. And if it has a decimal point, it's also going to return false because, again, not a number character. If the input is not a positive integer, then we enter the if statement. The print invalid input is going to be output, and then we use the continue statement to restart the loop. This is important as it means we don't do anything down here. So we don't add anything to the total, and we don't increment the count. We just skip these and restart the loop. We would also get an error if we attempted to add something such as duck or pizza to the total. So this is a good thing because we don't want to have our program crash if the user inputs something silly. If the input is valid, then we would run these lines, which convert the user's input to an integer and add it to the total. Remember, we have to convert any text input by the input function because it inputs these as strings. So since we're adding these to a total, which is an integer, that means we have to convert them to the integer first. This also increments the count by 1, as we just saw another valid input. The last if statement outside of the loop simply checks that the user input at least one valid number. This is important, as if we don't check that the user input at least one valid number, then we're going to get a divide by 0 error, because total and count would still be equal to 0, and 0 divided by 0 causes an error in Python. One interesting thing in the final output is that we are using a format specifier in the f string on the last line to round the output to a single decimal place. That would be the :1f. 1 here means one decimal place. F means float, because this is a floating point value that we get after we divided total by count. So let's take a look at how this works in Python when we run it. Okay, we have the program running now, and I'm going to input a few positive integers. 10, 5, 0, those are all positive integers, so they're valid. Let's try something invalid, like duck. And you can see it just says invalid input, please enter a positive integer. This is one of the great things loops can do. Instead of the program just exiting and saying error, we can keep asking the user for correct input, and when they make a mistake, we don't necessarily have to exit. Let's put a few more invalid inputs. -3, that's going to be invalid. 1.4, invalid. And now a valid value like 100. To exit, we just type in the word exit exactly. That's our Sentinel value, and that signals that we're done inputting numbers and to end the loop. And we can see that we get the average of the 4 valid numbers, and that is 28.8. And this program seems to be working correctly. So if this example is at all complicated or unclear to you, I highly recommend trying this out in Python, maybe playing around by modifying a few lines, and see how that changes the output. We have all of these examples for you on Owl, our learning management system. If you're watching this video embedded in Owl, you should be able to see a box down there that says video resources with all of those files available. If you're watching it on YouTube, you'll have to log into our learning management system and download them from there. You can also try running this in an IDE like PyCharm, which allows you to run code in debug mode and allows you to see how the variables change and go step by step through the program, which can be a great way to learn. Also, if you have any questions about it, you can always post to our course forums. Now, that's all I have for you in this video on while loops in Python. In our next video, we're going to be exploring more loops. Particularly, we're going to be taking a closer look at for loops. We saw those mentioned at the beginning of this video, but we'll actually get to see some examples and try them out in the next video. It's important that you know both, so make sure you watch that video as well. Thank you for watching, and have a great day.